For this problem, we're given a table. We want to use the information in this table to write a function for the population in millions of some town T years after 1960. So in the notes in this problem, it said let t equals 0 represent the year 1960. Now because this is a linear function that you're finding here, that means you should be able to use any of these points to use, but to make it easier, I'm just going to use the first two since those are the smaller ones. Now if it says let t equals 0 represent 1960, that means that the first point you're going to have is going to be 0 and 11.9. So you're letting t equals 0 represent the year 1960. So then if you wanted to represent the next point, 1970, that would be 10 years after 1960. So I would have 10 and 14.3. So now I can use this information to find the slope. I can do change in y over change in x. Now it doesn't matter which order that you subtract these in. If you're doing top minus the bottom, you want to do top minus the bottom there, or bottom to top. It really doesn't make a difference as long as you subtract them both in the same order. On top, I'm going to do 14.3 minus 11.9, so bottom minus the top. That way it remains positive. Now I do the same thing down here. I'm going to do 10 minus 0, just like that. I'm going to subtract these. So by subtracting those, that's going to be a 2.4. And then you're dividing that by 10, which means that the slope is going to be 0.24. Now I want to take this information and want to write the linear function. Now we have to remember to use the notation, the variables that it told us to use. We don't want to just put y equals because that's not a function and it's not using the letters that it's telling us to use. So a function p with t as the variable, that means you're going to write that as p of t. Okay, that would be the correct function notation. Now the slope is 0.24. So we are going to write this for slope-intercept form. So mx plus b. Instead of an x, we're going to use a t here in this case. So we're going to do 0.24t. Now we have to write the b. Now the b would be the y-intercept. Now actually, that's going to be this original point that we have. Whenever there's a 0 in the first position there, that automatically means that that's going to be a y-intercept. So the b is actually going to be this number right here, 11.9. That's going to answer the first part of the question. It says write a function for the population at time t. That's it right here. That would be the first part of it. Now the second part says estimate the population in 1975. Okay, now to do that, we're just going to put 1975. First of all, this formula, remember, the t represents the number of years since 1960. So we're not able to put 1975. You don't want to put that in there. Instead, you want to see how many years 1975 is after 1960. That's 15 years. So instead of 1975, you want to put 15 in there. So the way we write that is p of 15 equals 0.24 times 15 plus 11.9. So when you put that into the calculator, you're going to get 15.5. And remember, these are all in terms of millions because on the table here, these are already in millions. So that's why I don't need to worry about adding extra zeros on this table when I plug numbers in. I just need to know that these are all in terms of millions, which means that my answer that I get should also be in terms of millions.